We have completed the creation of MCD signals. Next, we will move on to the important phase of PLC programming. Once the MCD signals are created, the next step is to perform PLC programming in TIA Portal. Open TIA Portal. Create a new project. And save it in the appropriate folder. Open the project view. The first step is to configure the setup. Add a new device. Selecting the 1500 PLC SIM Advanced. And you can choose any order number and version number. After opening, the first step is to create variables. You can enter them manually, but a faster method is to export signals from MCD. In the electrical, there's an option to export signals. Allowing you to use the signals you created in MCD. This table includes signal names, their data types, the names of the signal adapters, whether they are inputs or outputs, and their current values, among other details. These are the inputs from MCD. When we create them in PLC, these signals will serve as output signals. Sensors in MCD are outputs, so for PLC, they become inputs. We can directly copy and paste these signal names. The first four are inputs in MCD, so in PLC, they will be the opposite, using Q points as output points. For the third sensor, we'll use M, as this is a virtual PLC. And we don't need real-wide contacts here. After creating these signals, modify the addresses and then create a few more signals. One for the start button, one for the stop button, one for the variable, and one for the program block. We will change the data type for the program block. This covers all the variables needed for this case. Next, we will go to the main program block to start programming. The first segment is for the start-stop function. the next instruction begins at step 0, as it always starts from step 0 when stopped. Since everyone's programming approach may differ, we won't demonstrate the entire programming process here. I will only provide a reference program. For those who find it difficult to create their own, can refer to my program for controlling the MCD. The first segment of the start-stop program begins with the conveyor belt starting up. When the second sensor is triggered, the conveyor belt stops, and RMID information collection begins. After stopping for 2 seconds, it proceeds to the next step, where the fuel cylinder retracts. Since it is extended during the reset state, retracting the fuel cylinder means it needs to be set to on, which will use the speed parameter. The fuel cylinder retracts to its position while the conveyor belt starts, reaching the second position marked by sensor 2. When triggered, the conveyor belt stops, and the first fuel cylinder resets. After stopping the conveyor, the pushing cylinder activates, giving it 5 seconds before moving to the next step, which starts the engraving process. Once engraving is complete, it proceeds to the next step, where the pushing cylinder and the fuel cylinder retract. The fuel cylinder 2 also retracts to its position, and the conveyor belt starts again, stopping when it reaches the third position, which is triggered by sensor 3, at which point the fuel cylinder 2 resets. Now let's explain the connection between PLC signals and MCD signals. Open PLC Sim Advanced, and in the triangle symbol, input 3 letters or numbers, or a combination of both. Click Start. When the light turns yellow, it indicates that the system is ready. Next, we will download the PLC program into PLC Sim Advanced. First, compile the program. If there are no issues, proceed to download. If an alarm appears during the download, right-click on the project, go to Properties, and enable Support Simulation during block compilation. After that, download the program again. Load it, and start the module. Enable monitoring, and once the program is ready, return to MCD to connect and configure the overall signals between PLC and MCD. In the Automation menu, first configure the external signals. Select PLC Sim Advanced to add the instance. Open the running instance. Click to update the marks, select all, and then uncheck the unnecessary variables. Click OK. After completing the external signal configuration, proceed to the second step, which is signal mapping. At this point, ensure that the selected type is PLC SIM Advanced and that the instance is the one we named earlier. The left side contains MCD signals, the right side contains external signals. You can directly execute automatic mapping. As it relies on the consistency of names between MCD signals and external signals. This is why we copied and pasted the names earlier. If the names do not match, manual mapping will need to be done one by one. Click OK. After completing the mapping, we can test the program. Click Play to open it. Here, you can manually modify its values. Start it, and then reset it. And observe the effect of the PLC program controlling the MCD model. If you need to stop the process, you can click Stop in MCD, or select Stop in the PLC. Either option will halt the operation. This concludes the demonstration of the laser marking unit case, including MCD settings, PLC program configuration, and the connection between PLC signals and MCD signals. Through this case, we reinforce the knowledge gained from previous case studies regarding the setup of physics objects, actuators, sensors, signal and signal adapter configuration, signal mapping, and more. By using PLC to achieve logical control of the MCD model, we primarily utilize PLC ADV to enable communication between the two, ultimately achieving a virtual simulation effect. This allows students to gain practical insights into the logical control of the intelligent laser engraving unit within an automated production line.